Okay, I'm back. I have decided to run this with API 19 instead. I'm having some kind of a problem still with API level 10, although it should work with API level 10. Um, it was earlier in the day for me. It is not now, so I'm just going to run with API 19 and show you guys how this cube actually works. So let me pause the video again really quickly while this installs the platform framework and boots up. By the way, my problem turned out to be one of antivirus protection being a little too overzealous. If you run into something that says panic, cannot launch emulator ARM, you will want to turn off your virus protection for a little while, or add it to the list of exclusions, which I couldn't seem to get to work, so instead I just turned my virus protection off for a short while I record this video. Let me know if you have that problem. I can probably walk you through it. But in any case, here I am with API level 10. I want to run this and run my GL example. And here we go. Here's my GL cube. It kind of changes dimensions over time and rotates, and that's about it. Pretty basic stuff, so nothing too fancy here. Here's how it works. Basically, there's a namespace for samples, GL cube, and there's an activity, a cube activity, which basically just does a create. It calls the base class. Remember that to call the base class of a create function, all you do is say base.onCreate, saved instance state, and then we have to inflate the UIL from the XML layout, which in this case is the main.xml. See where it says resource.layout.main? That's how you know it goes to the main XML layout right there. Next we load up the view. We do a find view by ID, painting view. Painting view is here, defined here, which is Android game view. The Android game view is a custom-made game view. We've kind of come full circle at this point. We're talking about games. This is the last video of the app LOOC, and here we are talking about games again. Android game view is a specific view made just for things like OpenGL, and you can draw game graphics to it, so it's kind of nice that way. We've got on pause for the cube activity, just in case we exit out of it and have to pause it, and a resume for it as well. Okay, so nothing too fancy here. Basically, the painting view is what's going to actually be responsible for initializing the cube. We've got a array, which is going to be our rotational array, and our rate of rotation in degrees here. And basically the painting view is going to call its base class, and then it's going to initialize. Initialization is going to do the rate of rotation for it, which is going to be 30, 45, and 60. We're going to create a frame buffer. As I mentioned before when we were covering XNA, frame buffers are basically a way to draw everything on the screen before it gets drawn and sort of populate, and then it renders it out pixel by pixel onto the screen. So each of these pieces of the rectangle is an actual pixel on the screen, and it's getting drawn out one by one. The Android graphics mode is being set here. This is what allows us to do GL. And if you take a look at that, this basically says that it creates an Android graphics mode instance with defined settings. It sets to EGL 1.x, and we're using the OpenTK framework here, which is what allows us to do OpenGL on the Droid. And then we do a create buffer, and then we create the GL cube. So in onload, we're going to call a delegate. We're going to basically say update frame with this constant speed. So they're called by the render loop. And this is what takes effect when we use run. And that basically modifies the rotation. Args times time. This is a standard way of modifying rotation and modifying things in game speak, because basically the rate of rotation of the current rotation times the time is going to give us a part of that rotation as time goes on. And then we're also going to create a delegate, which is render cube, and that's going to render our cube. Render cube is a pretty simple function itself, which basically says, creates a GL viewport, sets it in projection mode. So this is going to be a projection in for our cube, and it's going to be orthographic specifically, and these are the coordinates that we'll use for setting that up. And we're going to do some rotations. So we do a rotate, GL rotate of the rotation 0, 1, and 2 in the X, Y, and Z. So this is the X, Y, and Z. So X of 1. So it's going to rotate by 30 degrees in the X. Then 45 in the Y. And then 60 in the Y. This is messing with the color a little bit, doing a clear color. And we're going to be basically changing that over time as well. These are our initial settings for the cube and our vertices. So in 3D space, basically, this is defining all the extents of the cube. So the top left, top right, bottom left, bottom right, and then far bottom, far right, far bottom, far top, etc. And these are all the various colors that are going to exist in the cube over time. And when you see it running, you see basically that the corners have well-defined colors, like red, for example, and blue and yellow, and then towards the middle they blend together. So that's basically our cube. Nothing too fancy here. We've got a main XML layout, which is going to be pretty basic. It's just a painting view, as you created here, monosamples.glcube.painting view, and that's going to just do a fill parent, and that's just going to fill up the screen with our cube in this case. And and that's going to set that all up there. I want to take a moment to point out the Resource Designer. Resource Designer is very simple for this one because basically there's only a main XML, but it's always going to give me a unique ID in here that's auto-generated from whatever is in layout. So layout is our GL cube with our painting view, and it then creates main here. It also does the same thing for app name and painting view, which is the view in question. And so that's about it. Basically, the specifics of OpenGL, I don't expect you to really remember, not for the purpose of the quiz either. I might ask you some basic questions about what a frame buffer is, for example. And that's basically to prepare it for rendering. but I'm not going to ask you anything specific about rotations and coordinates, because this is kind of an advanced topic that we cover in the computer science program under the computer graphics course. But for now, I just wanted to show you something very basic and show you that yes, you can do 3D on Android using Xamarin. So that is about it for today. Again, I just want to remind everyone, if you do have that problem with the Android ARM thing for your virus protection thing, I'm currently shown as being unprotected. I'm going to do a resolve all on that quickly. I'll show you what ended up happening, and I've got to fix this on my end as well. If I go to my virus chest, it's the emulator ARM exe that needs to be excluded. So you have to do a restore and add to exclusions right there. Overwrite all on that. So that is it for the LOOC. I want to congratulate everyone on making it this far. Everyone that did make it this far. If you're listening to and watching this video, odds are that you've made it through the entire course. Good job on that. And in about 10 days from now, we will have the final app due, which is a mashup or a slight customization of one of the sample tools. That concludes our content for Unit 12. Unit 12 was lighting content. I think I had one video that was about 20 minutes, one that was about 8, and now this one's about 12 minutes long. So we end with only about 40 to 45 minutes worth of content for Unit 12. But some of these units we had, as you know, 3-4 hours of content. So this one we wanted to be a little bit light this week and give you guys a chance to use that extra time to come up with some cool apps to create using the Xamarin products. And if you've got any questions, please let me know. I want to take a moment also to plug the app camp that we have going on. If you type in UWGB Summer Camp Games, something like that, you will see the video game programming camps listed. The URL is uwgb.edu/camps/science/videogame. Unfortunately, for you guys at least, the level 1 camps are full. These are Game Maker camps. The level 2 camp has about 3 seats left. You would certainly qualify to get into level 2. We're using Unreal Game Engine in this, which is actually what I'm using on minimum currently, and what I used on Batman Arkham Origins. So it's a full-featured game engine, and we're going to be using that. That's July 20th through the 24th. We're also doing a beginning app development course, camp, basically. This one has about 10 openings left, I would say. For this one, we're using App Inventor, which is actually a lot easier to use than Xamarin. Almost requires no programming, kind of drag and drop structured. So that should be pretty fun and pretty easy for you to do. And each one of these comes with books that you'll be able to take with you. We have quite a bit of fun in the course. Here's some pictures of people making games. We had some pretty cool games made last summer. Some of my favorites came out of that, and I'm hoping to see even more this coming summer. So check that out, and again, thanks for partaking in the LOOC. This was an experimental journey for all of us, and I congratulate you for making it through. Good luck on finishing your apps. All right, over and out.